All right, thank you all for attending a session this afternoon. Hopefully you're in the right room. We are here with Dan Snelson for Jamf Pro Performance Tuning Extension Attribute Audit. Great. Thanks, Dan. We're excited. I'm Kristen. I'm your room host. If you need anything, let us know in the back of the room. We will have time for question and answers at the end. I'll run microphone over to you, so wait for me to get there. But we're really looking forward to this. Thanks, Dan.
Happy Tuesday, Denver! It is great to see everyone at yet another spectacular JNUC 2025. My name is Dan Snelson, and I am a senior system engineer with the Church of Jesus Christ of Latter-day Saints. We are sometimes called Mormons because of our belief in a volume of companion scripture to the Holy Bible called the Book of Mormon. Let's talk about how to tune your Jamf Pro server by conducting an audit of your extension attributes, because nothing says fun like an IT audit. We'll start with Sir Dave Brailsford, the former performance director of British Cycling, who popularized the aggregation of marginal gains. This philosophy focuses on making small improvements across the entire enterprise, often as little as 1%, which, when combined, lead to significant overall performance enhancements. Brailsford applied this strategy to transform British Cycling from a historically mediocre team into a dominant force, achieving remarkable success, including 7 out of 10 track cycling gold medals at the 2008 Beijing Olympics, a repeat performance at the 2012 London Olympics, and multiple Tour de France victories. Brailsford's philosophy emphasizes that the cumulative effect of these minor changes compounds over time, leading to extraordinary results. He noted, if you improve by 1% every day for a year, your performance will improve by a factor of 37 times. However, if you take a standard 365-day calendar year in the United States, accounting for federal holidays, weekends, and assuming a 5-day work week, then abolished Monday mornings and Friday afternoons, you would arrive at approximately 225 days. So if you improved by 1% every day for 225 days, your performance would improve by 9 times. Here's our agenda. We'll start with a quick overview and then discuss how to establish a baseline for your extension attribute execution time. The bulk of our time together will be performing the actual audit. We'll then review our findings and finish up with resources and Q&A. Also, I want to mention that before I leave this room, I'm going to click Publish on a blog post which contains all of the links mentioned throughout the presentation. So while there are multiple QR codes, you can just go to my site and have all of the reference in one place. Let's start with a brief overview of extension attributes. Computer extension attributes, which allow a Jamf Pro admin to collect extra inventory information, are one of my favorite features of Jamf Pro. Using the script input type, almost any client-side setting can be collected and acted upon. Here's a QR code from Steve and Lee's extension attribute session from JNUC of 2024. Our first step is to establish a baseline for how long our extension attributes currently take to execute. Let's look at a demo of using the time command in macOS Terminal on a fully enrolled virtual machine. When you prepend a command with time in macOS Terminal, the total reported time represents the wall clock time taken to execute the command. This is the elapsed time from the moment the command starts until it completes, including all system time, CPU time, as well as time spent waiting for I/O and other system activities. In a previously elevated terminal window, we'll enter time sleep 2 as a simple example of preceding commands with time. The value before the word total is what you'll want to capture. Let's now look at the execution time of an inventory update via time Jamf recon. Again, the value before the word total is what you'll want to capture. So that was a demo of using the time command with Jamf recon in an elevated terminal window on a fully enrolled virtual machine to establish a baseline of how long an inventory update actually takes. Let's look at a demo of using self-service to establish our baseline. We call self-service the Workforce App Store. Execution time for an inventory update can be displayed to the end user with the use of a custom script. Duration is also available in the Jamf Pro policy log. Here's a QR code from last year's JNUC session on user-friendly inventory updates. Here's a QR code for the GitHub repository we'll be using. Let's look at some demos of how to use the EA audit scripts. Our first demo is leveraging the EA download script. We'll start by visiting GitHub and downloading the actual script. In Finder, we'll create a dedicated EA audit folder and option drag the script to create a copy. Let's review the script in VS Code. We'll change log level to debug, then save the changes. While we do have a previously elevated terminal window, we'll open a new tab in Terminal, then enter the displayed command. Here we can see the commands to add the Jamf Pro API credentials to our login keychain. We'll switch to Jamf Pro, and in Settings, we'll create an API role and client. Looks like we need the Read Computer Extension Attributes privilege. We'll save the API role, then create the API client. We'll generate the client secret, copy the credentials, and head on over to VS Code. We'll tell VS Code we're working with a snippet of JSON. Increase the font size and enable word wrap. Back in Terminal, we can copy pasta the entire first line. With the next two lines, we'll have to copy and paste the start of what's displayed in Terminal with the end of what is displayed in VS Code. Okay, with the credentials stored in our keychain, we're ready to test. Wow, that was fast. We have a timestamp directory with the raw JSON and a log file and a scripts directory with the actual EAs. So that was a demo of leveraging the EA download script. Here's a demo of leveraging the EA execute script, which can help determine the actual execution times for each of your extension attributes. Looks like before we can execute anything, we'll need to first download the extension attributes. Again, while we do have an elevated terminal window, we'll want to create a new tab since we want to leverage our login keychain. Got 'em. Let's change the log level to info and save the script. We'll rerun the download script, and notice the output is a tad quieter. Returning to GitHub, let's download the EA execute script. We'll option drag to our working folder. Then review in VS Code. We'll head back to terminal. And observe that the EA execute script must be run as root, since that's how the Jamf binary will execute our extension attributes. Second try, this time in our previously elevated terminal window. Oh! Looks like we need to include our scripts directory. All right, third try's the charm. Hold up. That was way too fast. Let's look at the log file. Yeah, I think we've hit a limitation of testing on a virtual machine. So let's employ some movie magic and switch to physical hardware. Here's take two of leveraging the EA execute script, this time on physical hardware to better match reality. We're on a new Mac, so we'll need to start from scratch, but this will give us a chance to review how to get set up in double time. We'll start by creating a working directory, which I like to call EA Audit. Visiting GitHub, we'll first download the EA download script and option drag it to the working directory. In terminal, even though we have an elevated session, we'll want to create a new window for our account to properly store the keychain entries. Oh, that's right, we need to include help the first time. In Jamf Pro, let's rotate our API credentials, which will break our configuration on our VM, but I don't care. We'll then configure our keychain entries as before. All right, we're up and running again. Let's trash the timestamp directories from our first two attempts. With the EA scripts downloaded client-side, let's grab the EA execute script from GitHub. We'll again option drag to our working directory and run it. Oh, again with a root. We'll switch to our previously elevated terminal session. Oh, double dope. Got to supply the scripts directory. Victory. Oh, I can feel that SSID is going to need some optimization. Yeah, the SSID EA is taking more than 5 times as long as the next longest one. So that was a demo of the EA execute script, this time on physical hardware to better match reality, which can help determine the actual execution time for your extension attributes. And I think we have already found our first candidate for optimization. Let's leave the SSID EA for now and shift gears by looking at a demo of optimizing a single extension attribute, which has a fairly high execution time. In Jamf Pro, we'll look at a list of our extension attributes and the recent addition of pending software updates. We'll note that this is being displayed in the operating system section of our computer inventory. We'll then observe that this Mac has a pending software update for macOS Tahoe 26 Beta 3. Useful information, but it's just adding too much time to each inventory update. Since this is a recently added EA, let's download and execute a fresh copy. There's that SSID we need to work on. And yes, the pending software update does feel slow. Reviewing the execution summary, we can see our new EA is also the slowest of the bunch. Let's take a look in VS Code. Looks like we have a line of code commented out just for this demo. Let's focus on that. So in our elevated terminal window, let's check the output of this command. Interesting. Let's return to VS Code and uncomment the 3 commented outlines and re-execute. Not much of an improvement, but there is an actual pending update. Let's employ some movie magic and update the OS in a blink of an eye. Ooh, cool new desktop in Beta 3. In a previously elevated terminal window, let's rerun our plist buddy command. No pending updates. Let's time software update. Still more than 5 seconds. Let's re-execute our EA scripts. There's that blasted SSID again. Wow, this time, when there aren't any pending updates, our script took less than 0.03 of a second to execute. So that was a demo of optimizing a single extension attribute, which had a fairly high execution time, by first referencing a separate, seemingly unrelated client-side plist. Okay, we've ignored the SSID EA just long enough. This demo involves leveraging an additional custom EA frequency code wrapper to control how often time-intensive extension attribute code is actually executed. Once you get it implemented on one EA, it's as easy as pie to quickly optimize your other time-intensive EAs. We'll start by opening our entire EA audit folder in VS Code. And we'll review the execution summary section of the log file. Here we indeed see that the SSID EA takes more than 5 times as long as to execute the next longest. Let's drill into the actual code. Here we see we're leveraging the generally time-consuming system profiler binary, but it does work in this beta of macOS Tahoe. Copy pasta the snippet and proceed it with time. And we've confirmed that this command is the culprit. Let's uncomment the commented out code to enable EA frequency. A sprinkle of movie magic, and we have an elevated terminal session. We'll start with the now familiar time command and then VS Code's run active file. The first time through, we're not seeing any performance improvement, which is to be expected. On a subsequent run, however, we observe significant improvement. So that was a demo of modifying the extension attribute code to leverage an additional custom EA frequency code wrapper, which controls how often time-intensive extension attribute code is actually executed. Next, let's look at a high-level overview of EA frequency, as well as provide yet another QR code. Here's a high-level overview of how we've implemented the so-called EA frequency code wrapper functionality for our time-intensive extension attributes. During enrollment, we deploy several functions client-side for quick and easy use in other scripts. EA frequency and EA result are just 2 examples. As one of the first steps of an extension attribute script, you pass the name of the extension attribute and the desired frequency in days to the client-side function. A client-side plist stores a timestamp epoch and the result. During subsequent inventory updates, the plist is checked, and if the current epoch is less than the given frequency, it just reads the previous result from the plist instead of executing the entire extension attribute script. Here's a QR code for a blog post with more details. Now for our findings. In general, 20% of the total execution time, 80% of the total execution time is most likely to be caused by only 20% of your EAs. In our earlier SSID example, we observed that just one extension attribute accounted for more than half of the total execution time. which is why we conduct regular audits. When determining the max SSID, we leverage the EA frequency code wrapper, and dividing the original time by the optimized time, we observed an improvement factor of 45. With pending updates, we first checked a seemingly unrelated client-side plist before executing the time-intensive software update binary to determine which updates were available. No pending update, no need to check. Again, dividing the original time by the optimized time, boom, 185 factor improvement. Here's a summary of our findings. Once you've identified the extension attributes with the greatest execution time, look at fine-tuning your code. You'll most likely discover that this is more art than science, and the Mac Admin Slack scripting channel is a great place to brainstorm. Or, if you're a tad too embarrassed to publicly share your scripting skills, try the AI route. A word of caution with AI. In my experience, AI isn't currently capable of connecting the dots. And you may find yourself going further and further down a dead-end rabbit hole with AI when you, as a reasoning individual, just need to reset and look at the individual trees which make up the beautiful forest. If you have an EA which doesn't need to be executed with each and every inventory update, give the EA frequency code wrapper a try. Also, please be aware that script extension attributes can be temporarily disabled with a few clicks while maintaining the latest data. If, after a week of having the EA disabled, you may find you can simply delete it altogether. Finally, I'm sorry, that was my fault. Can you go back one? Kristen, could you bail me? Oh, maybe I can bail myself out. That was me. Okay, here's the findings again. You want to hear a boom again? Boom. You got to do it from the diaphragm. Okay. All right, we're getting through these. Fine tune, EA frequency, disable. Okay, here we go. Finally, we have been looking at the EA execution time in a vacuum. You're going to realize these gains across your entire fleet at least twice a day, every day. Do you manage a few hundred Macs or several thousand? There are some real gains to be had here with a couple of afternoons worth of work. Well, that's it. So here's a QR code for all of the extension attribute related posts from my site. Before I leave this room, I'm going to click publish, and then the most recent post on my site will be these notes. What questions can I answer?
If you raise your hand, I'll bring you a microphone.
Way over here, Kristen. Oh, you got somebody there.
This covers optimizing the client-side performance. Have you looked into how best to optimize like the database end, like the actual data in the EAs?
So have I looked at the result of this optimization? Is that the question?
Yeah, I guess, or just maybe more how to optimize your Jamf Pro server with the number of EAs and that type of thing.
So I think what's going to do the most optimization is to limit the number of times you update inventory. Jamf recommends twice. Last year's presentation was on inventory update and optimizing the database. Ultimately, the value that you're storing in the database is going to be identical when you're done with your optimization, right? It just takes less time. I hope, I don't know if I answered your question, a thumbs up. Okay, there was somebody way over here. Thank you for those who are leaving. Not thank you for leaving, but thank you for being here. Come back and see us next time, please.
I have a hypothetical.
Please.
A hypothetical of...
And may I first say, I don't mind working in theory as long as I don't get paid in theory.
Got it. Got it.
So let's go. What's your hypothetical?
Multiple EAs.
Okay.
20, 30.
Okay.
That run on every Mac that gets provisioned.
Yeah.
In an on-premise Jamf instance.
Yeah.
Managing 37,000 Macs.
Nice.
If there are delays in those EAs, would that affect Jamf binary issues or MDM enrollment?
Yeah, absolutely. Absolutely. And that's the challenge, right? You can't scope EAs, right? They are going all the way. So my first thought is I've got a little snippet of code. If you'll hit me up on the Mac admin Slack, what this snippet of code does, it just looks at the date of Apple setup done. And if it's not greater than 24 hours, it just skips it. So you give, the first day, just forget it, or however many hours you want it to be. Maybe the first hour is critical. And so as long as Apple setup done is older than 2 hours, then run this EA. Now, there's going to be a lot of work putting that into every EA, but 37,000, you're going to get a big benefit. And hit me up after if that doesn't answer your question. And Kristen, I can only see questions that are on the opposite side of where you're standing. So I don't know, was there somebody over here? Or? Oh, right there.
Hello. My question is, your optimization tools look like they're written in Z Shell. Will they also work with EAs that are written in Python?
I'm having a hard time hearing you. I do have hearing loss, and that thank you.
My question was, will your tools work with EAs that are written in Python?
You'll have to adapt them and then do a pull request so that we have both languages.
Thank you.
But the theory's there, right? You'll see the theory and go, okay, this is how I would do it quicker and easier in Python.
Besides the gain of time for these utilities, are you trying to fit in more extension attributes to be used rather than having such a huge delay? Was there any other points that you were trying to create rather than just time saving for you personally?
So the first time, that's an excellent question. The first time through, we looked at the laundry list of EAs and we're like, are we really using that? And Leslie wrote object info. I think a lot of smart groups are now built in. You get reports built into Jamf Pro, right? So if you drill into a smart group, you go to reports, you can see where it's being used. I was using Leslie's object info before. So the first time when I wrote the blog post originally, we got rid of stuff we weren't using, right? Because you start as an admin, hey, I can do this, look at it, and you just do, right? Because you can, you do, and you shouldn't, right? You got to do the Jurassic Park theory. So now, when I was writing the blog post that I'm going to click publish before I leave this room, I was interested in time. And if something was less than a second, I'm like, okay, diminishing returns. There's no way I'm not gonna get it less than, it's already less than a second. I'm not gonna get it less than a second. But I had one, I'm embarrassed to say, it was like 22 seconds. And it wasn't any of these that I showed here. Like, okay, I gotta eat my own dog food, let's try it. And when I hit the publish on the blog post, you'll look and go, oh, okay, very good. Or anybody else? I have a brain date set up for tomorrow that had some spots open on it. I have a brain date set up for Wednesday that is full, but I found out from the brain date desk that if you go there, and this applies to everyone, that's not mine. If you'll go to the brain date desk and say, hey, can I kind of go in and join this? Because there's only like 6 spots in the app, but physically there's more space. They'll put you at a bigger table. So I've got some opening. Last time I checked, I had openings for tomorrow. An opening, well, Thursday's full, but there were some openings on Wednesday. And I'm happy to hang out here afterward, last session today. You can hit me up with anything you weren't comfortable publicly asking. Okay, thank you.
The other thing too, there is a survey at the end of each session. Make sure you're filling it out so we know what feedback you have. Thank you all for attending. Hope you had a great day.
Yeah, it'll help me if you do the survey, because that helps me justify to my employer the time I spend doing this. Thank you.